this question from AtCoder Beginner Contest 161, Problem E, Yutori. The problem statement states that Takahashi has decided to work on key days of his choice from the end days starting from tomorrow. Okay, you are given an integer c and a string s. Takahashi will choose his work days as follows. So after working for a day, he will reframe or not work from working. So after working for a day, he will not work for the c subsequent day. So if he works for on the second day, he will not work for the c consecutive days, and he will only work after those days. And if the ith character is x, he will not work on the day I. So it means if there is a day which has cross on it, so it means you can assume it that that day is a holiday, and Takahashi will cannot work on that day. So find all the days on which Takahashi is bound to work. Okay, so you will get the question more clear with the example. So as you can see, there are 11 days, and 0 means that Takahashi can work on that day. So he just have to work on 3 days. Okay, and now he have to, after working for one day, he will not work for 2 days. So if he works on the first day, he will not work for these 2 days, and because this is also holiday, so he can only work on this day again. Okay, so the possible combinations for the 3 days can be, he can work from the first day, then on the sixth day, so or and on the 10th day. So this will be more clear with this example I've drawn it here. So if he work on the first day, then because c is equal to 2, he will not work on the next 2 days. So he will not work on this day, so the next day will be this, and then he will not work on the next 2 days, so the next day will be this or this. Okay, so he will work on this day, or he can work this day or this day, or he can work this day and then this day and this day, or work this day and this day. So there are possible of 4 combinations, but as you can see, in all the 4 combinations, this day is always there. So he has to work on this day. Sixth day, he has to always work, irrespective of whatever possible combinations he will choose to work on the sixth day. He has always have to work. So the answer is sixth. So there is also one more example on this. So as you can see, if for this c is equal to 3, okay, and he has to work for 2 days. So if he work on this day, now he has to work for the not for the next 3 days. So he can only work on this day. Now, if he works on this day, he will not work for the next 3 days, and so then he will not be possible to complete both the two tasks, both 2 days. So he must always have to work this day, and then after getting a leave for 3 days, he will only work for this day. So irrespective of whatever he can do, he has to work on this day and this day, because this is the only possible way. So he has to work on the first day and the fifth day. I hope you understand the question. So what you can do is, as you can see, if we just choose any two of the possible scenarios and see what are the days which are common. So if we choose, starting from this point, if we just greedily assign all the days to Takahashi and see whether he on the when we start at this day and greedily choose days, or what are the days he has to work. So if for this, if we just move from left to right, and we'll see he has to work on the first day, and then he don't have to do those 2 more days. So now the next day will be sixth day. So now he has to work on a sixth day, and then he will not work for the next 2 days, and now he will do on this day, which is ninth day. So this can explain us that if we choose from the first day and greedily assigned, after skipping the 2 days, whatever the next 0 comes, he will choose that day. Then he will not do for the next c days, and whatever the first 0 arrives, he will work on that day. So we are just greedily choosing zeros after jumping off the c distance. So if we move from here, this will be our schedule. Okay, but if we again find out one more schedule, so we can find out that in both these schedules, these days are common, in which means that whatever he will choose any schedule among these two, these days are always present. So if we can find out those days, so but what is the how we can choose the next schedule? If we start again at this point, we will greedily choose those points, and the answer will be same. But what we can do is we can start from here at the start, because the days we have fixed number of schedule, like how many days we can work, how many not. So if we start at the back, he has to first work on this day, which is 10, and then he will skip 2 days. So he will now work for the next 0, which is 6, and then after he will again skip now 2 days. So he will now work on this day, which is 2. So now, as you can see, in both of these schedules, only 6 is the common day, which means if whatever schedule between these two he choose, he has to work on the 6th day. So now that's the main thing we can do. For this same also, if we start from 0, he will have to work for the first day and the 5th day. And if you also again start from the back, he will choose on the 5th day and then on the first day. So it means now we get the answer is 5, 1 and 5, because both of the numbers are in, so we have to find out basically what are numbers which are present in both of the vectors if we make two vectors of both the schedules. I hope you understand the logic, such that we have to find out the common days in both of the schedules. Okay, so directly let's just code this question now. So what we can do is, in this question we are given n, k and c first. So n, k and c, and we can input them n, k, c, and then we are given a string s, input of the string s. Then we make a vector to store for both the days a and b. Now store for the, like when we are moving from the left to right. So int I is equal to 0, I is less than n, I plus plus, and we are greedily choosing. So if s of I is equal to 0, is equal to O, because it's O. So if we have found one day, so what we'll do is we push back that index of that day in the A vector, and then we will jump C days, because now we don't have to find out another 0 for the next C days. And then at this we have pushed all the days in this A. Now we have to move from back. Int I is equal to n minus 1, I is greater than equal to 0, I minus minus, and if same, so if s of I is equal to O, then what we have to do is b dot push back I, and I minus equal to C. So now we have pushed back all the like the values days in the two vectors A and B, and then we have to match. So how we can match? Because they are in reverse order actually. So we will start from the first value of the A vector and we'll match it with the last value of the B vector. So I is equal to 0, and because there are actually k days, so we'll iterate over I less than equal to k, and if like A of I is equal to B of k minus I minus 1. So if this is true, then what we'll do is see out A of I, but because our indexing is from 0, we'll have to add 1 and give a enter, and yeah, new line. And let's like first run this for any test case. This is the one of the test case. Let's run it. Yeah, so first submitted, it's giving 1 and 5. As you can see, 1 and 5 is the answer. So because 1 and 5 is for this. Okay, so let's submit this code, because like I think it's working fine, so we can just submit it. I hope you understand the logic. If you still have any doubts, please mention down in the comments. I'm reading every comment, and if you have more question suggestions, please mention on also, or any feedback for me. It got accepted. I hope you understand the logic. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Bye.